Hey people, welcome back. And today's session, we are going to learn about the selection of the control chart. So before we go for the control chart selection, there is an important question we have that why control? We know that we have done so much of work in the define, measure, analyze, and improve phase. And finally, we reach that we have achieved the metric. Now, the level of the metric what we achieved by improving the x variable like this. We want this x variable, we should be able to enjoy the relationship with the y variable, which means if we have done the work starting from here, we will improving the x and improve the y. And now we reach to the level where we wanted to achieve. We should be staying here. What level we have achieved. Again, the condition shouldn't be like as we are falling back to the ground level or the zero level. So there is a place which we want to sustain, and this is the place. We don't, whatever the work we have done, we don't want to fall down again from this place. To maintain this level, we need a control in our process. So the level what we have achieved, we need the control in our process. So there are two control. One, and the first thing, you should be practically meeting the value, which means what your process desired. Those value, those outcome you should be seeing from the process. Once you have the control on your business or the process practically, and then we look for the statistical control. Right? So to understand the symptom in a process of symptom of failure or symptom of going out of control, we plot SPC or statistical process control. Because practically you are meeting the value or not meeting is the first priority. If you are meeting, and again you should not be falling to the zero level from there it started. So what are the symptom in case your process is showing any of the symptom? To understand that, we do the or we implement control in a process, and those are the statistical control. So statistical process control, basically we plot the control charts, and there are two type of control charts we have basis on the data. Either your data is continuous or data is discrete. Sometimes we call as an attribute chart as well this. So for the continuous type of data, we mainly plot three type of control chart. Those are IMR chart, X bar R chart, and it is X bar S chart. IMR stand for individual moving range chart, which means you are plotting individual data as an independent data over a control chart, is called IMR chart. In case you are not plotting the independent data, you are plotting a subgroup of the data. So if I say subgroup size, in IMR chart, as the name says, one independent data. But when you are taking the X bar R chart, which is average and range chart, so we use the subgroup of 2 to 5, 2 to 7 basically, or maybe up to 8 max, not more than that. And this is your called X bar R, which is average and range chart, 2 to 8. And X bar S stand for average and standard deviation chart, where we are using the subgroup size from 8 to 15, not more than that. Because why we are using a subgroup 2 to 8 and using the X bar R and 8 to 15 in the X bar S? Because as per statistics, if you wanted to measure the variation in a data, and your subgroup size is less than 7 or up to 7, then the right measure of measuring the variation will be your range. But as the data sets are 8 or more than 8, the measure of variation we should be using is standard deviation. That's the reason this is the difference between the X bar and X chart. So subgroup size is up to 7 or 8, then we use X bar R chart, because for a small subgroup, range is a better measure of variation as per statistics compared to standard deviation. But as the subgroup size grows and it goes 8 or more than 8 but not more than 15, then we plot the X bar S chart. So these are the three type of control chart we'll be learning soon. Now, if I go for the discrete or the attribute data, so this will depend on what is the output you are looking for. Are you trying to look for the defect count? That means your sample size or subgroup size is constant. Out of a constant sample size, you are looking for the defect. Uh, then we will be plotting the C chart here. C chart stands for count of defect. Or in case you are looking for the defective out of a constant sample size, which means count of defective, then we plot NP chart. If you are looking for the proportion defect, so proportion we calculate only when the sample size is variable. Variable means we always calculate proportion. Constant means we always calculate count. So if sample size is variable and you are looking for the defect proportion, we use U chart. And if the sample size is variable and you are looking for the defective proportion, then we use the P chart. So what is the constant? What is the variable? Constant means you have used the same sample every time. Like as if you are using the audit, you are doing the audit. Today you are doing 10 audit, tomorrow 10, day after tomorrow 10, day after tomorrow 10. Like this every day 10. So this is the constant sample size. Variable means maybe based on the availability of sample or your time available. Sometime you are using 10 audits, sometime doing 12, sometime 8, sometime 9. So when the sample size is changing, it is called as a variable. So if you are looking for the defect out of a constant sample size C chart, you are looking for the defective out of a constant sample size NP chart. When you look for the defect of variable, then U chart. And when you look for the defective of variable is P chart. This is the way we do the control chart selection. I will be explaining you how to plot and interpret each of the control chart in the next session. Thank you so much for joining.